In this video, I'm going to go over my details on my conversion of the Z55 Predator, which came stock with two brushed pusher motors, and it was just 3-channel. So I converted it to a single pusher motor and nearly full span aileron. So now it's brushless and it's 4-channel, and it flies just absolutely great. My all-up weight with all the components that I chose for this conversion is 176 grams. I think that the motor and the prop combination I've got on there, comparing it with very similar motors, I think I'm getting about 340 grams of thrust on 2S with this setup. So it's got plenty of power. I would say very, very close to unlimited vertical with the weight and the amount of thrust I'm getting from it. All right, the first thing I did was disassembly. I did add a carbon slat, 1mm by 5mm carbon slat that's almost the full span of the wing. I just used some scrap plastic, 2 different pieces, one piece that is attached to the back of the fuselage, which I trimmed down to get the motor as close to that where that vertical stabilizer is as possible, so that I could get the CG with the 2S LiPo in front. You can see the 3 mount tabs there. I just used some 2mm nylon threaded screws with nuts to attach the motor mount, the half of the motor mount that's attached to the motor, to the other half of the motor mount that is attached to the fuselage. I've got those 4 holes cut out there so that the motor would fit flush with the second half of the motor mount, because I've got raised 4 raised screws that attach the motor to that first plate. So that allows everything to set nice and flat and flush with the 2 halves of the motor mount. So that's how I did that. You can also see here where the vertical stabilizer goes in, attaches to the back of the fuselage with the 2 screws. I cut a channel to bring the cables through, the motor cables, and I cut a hole on the other side of where the servo is sitting for the V-tail elevators, and drilled a hole all the way through to the equipment bay to bring the wires through. Now the foam that comes off the bottom of the vertical stabilizer is kind of like a V with a little centerpiece cut out of it. I trimmed the bottom of that off level about 4 millimeters so that it wasn't pinching against the cables coming from the motor. I didn't want the cables from the motor to prevent the vertical stabilizer from sitting flush against the fuselage. So I did trim that down a little bit, and that worked out great. I didn't have any problems with that whatsoever. The gyro that I chose is my go-to gyro, the Byme-A or the Byme-D. In this case, since it's a 4-channel plane, I'm using the Byme-A gyro. It's the V2. I've got 2 separate ailerons attached to the wing, one aileron for each, one servo for each aileron. So I'm using a Y cable to attach both of those to the gyro. My go-to receiver for these gyros is, for a long time now, has been the WFly RF201S SBUS PPM receiver. And the next picture, you can see I've glued in the carbon slat into that channel. I also took that top plate that goes over top of the 2 wing halves and attaches the main wing to the fuselage. I glued that in to further stiffen up that wing. I've got the brushed motors removed. I just left the motor mounts in place. What I did do so that the housings for the brushed motors wouldn't interfere with the operation of the ailerons. You see this little raised lip down here, these plastic lips for the motor, the brushed motors. I just took a Dremel tool with a cutting disc and I cut those off so that that housing is flush with the back of the wing. I just dry fitted the wing to the fuselage and then took an ink pen and drew these lines. So I knew where the outside of the fuselage was, where it met the wing. so that when I glued the servos to the bottom of the main wing, I could glue those as closely as possible to the outside of the fuselage. So I'm within a couple of millimeters of the exterior of the fuselage where it meets the wing. I wanted them as close in as possible to keep your center mass as centered as I could. All right, I didn't have any material that I could use that would give me a solid length of material to make nearly full span ailerons other than some sheets of 1.5 millimeter balsa wood that I had on hand. I just coated one side with the E6000 glue and then sandwiched the glue between two halves of the aileron. So each aileron half is two sections of 1.5 millimeter thick balsa wood. And so the glue really provides a lot of rigidity to those two halves of the 1.5 millimeter thick balsa wood. So I didn't have any problems with flexing or anything by doing it that way. All right, so here I've got both halves of the aileron assemblies glued together. I've got 6 micro nylon hinge assemblies up here. I used 3 hinges per section. I attached those to the plane. You can see that the profile matches the trailing edge of the wing pretty closely. And I've got the 3 nylon hinges attaching everything to the main wing. I just drilled some holes in the aileron assemblies to attach the control horns. My original thought process on this was to go with dual tractor motors. But the dual tractor motors were going to make it nearly impossible for me to get the CG where it needed to be, and it was also going to make it very, very heavy, and it was going to make it very, very difficult to get all the components and all the cabling inside that narrow little equipment bay without modifying the fuselage, to make it wider or make it deeper or both. So that's where these little squares came into play. Those were the motor mounts for the dual tractor motors that you see up here. I had to change gears halfway through this conversion and put a single brushless pusher motor and prop on it. I took the equipment bay, battery bay plate, access plate, and door. I cut all those plastic risers off of it except for the 2 where you use the screws to attach it, so that I could use that entire area there as my equipment bay. So I just shaved all those plastic risers off of it. I glued the door into the battery door into the plate itself, and then I glued the entire plate onto the bottom of the fuselage. So that's probably the weakest point on the fuselage. By gluing that plate on there, it's going to make it more solid and more rigid than just having those 2 screws, hold it in there, because it is kind of flexible. There's the servo installed. I did have to shave off a little bit of this foam right here at the front in order to get the servo to fit flush into the foam. I had to extend that pocket just a little bit and then glued it in place. All right, here you can see where I removed that center foam section, that center block that they had in their stock, because they basically had an equipment bay on one end and the battery bay on the other end. And since I'm moving the battery bay to the front of the fuselage, I wanted to use that entire area for the equipment bay, and that worked out really well. I was able to just get everything in there tucked away with the main wing on top of it. All right, and so here you can see where I used I wanted to cut off this top section of the foam, and I wanted it to look fairly nice. So I ended up fabricating a hot wire foam cutter, and that worked out really well. And then I just hollowed out the interior. I also hollowed out quite a bit of the top of the canopy, and then I attached magnets to the end of the canopy and the back of the battery bay here. So I've got a nylon hinge on the front and magnets secure the back of the hatch. Okay, so there's one of the magnets. You can see there's a magnet glued to the back of the the fuselage. So I just cut out a little tiny, real shallow pocket there to glue a magnet in there, and a little shallow pocket here to glue a magnet in there, and then I just put a little tape tab on there. You know, I drilled a hole from the front of the battery compartment into the equipment compartment, and then just ran that extension cable through there, and that worked out great. All right, here you can see where I've hollowed out part of the top of the fuselage, and I actually ended up hollowing out more of it because some of my batteries are a little bit heavier than others. Some of them I have to move all the way forward, some of them I have to move back a little bit. So in order to get that closed over those batteries, I had to hollow out the top of the canopy all the way back to where that about to where that tape tab is taped onto the back of the fuselage. So about 3/4, I'd say about 3/4 of the top of the canopy I hollowed out so that it fits nice and snug over top of the battery compartment. And I had to do that after I wanted a better way of securing those batteries rather than just relying on the magnet to keep the hatch closed. So what I did was I glued in some Velcro into the bottom of the battery bay and put some Velcro on the bottom of the batteries, which raised the batteries up just enough that I needed to hollow out that canopy. So now the batteries are nice and secure. I don't have to worry about the canopy popping open when I'm doing aerobatics and stuff. So it worked out really well. All right, and we're back to the finished product. So in the show notes, there's a link in there for the template that I created for the motor mount. The motor mount is for the 2004. The motor that I used is a Eachine branded AtomRC 2004. It's a T-mount motor. It uses T-mount props. 2004 2700 kV motor, and that worked out awesome. I have an HQ T-mount 5x3 polycarbonate prop on it. The batteries that I use are the same batteries, 2S batteries that I use in the XK A280 P51D Mustang. So there'll be links to those batteries in the show notes. You can buy them in pairs. They're fairly inexpensive. They work really, really well. They give me a great amount of power with this power system and a great amount of flight time. The ESC that I used was a ZTW Mantis 12 amp ESC. It worked out really, really well. I like the ZTW Mantis ESCs. I like the Hobbywing Skywalker 12 amp ESCs. The Hobbywing ESCs have been my go-to ESCs for the past couple of years because I've never ever had a problem with them, and they work great. So that's what I've got in here as far as the ESC. I already showed you the gyros, the Byme-A. The receiver is the WFly RF201S SBUS PPM receiver, Emax 2.5 digital servo. I did have to drill out that hole in the servo arm. I think I had to drill it out about 1 millimeter, maybe 1.5 millimeters to get both of those Z bends inside that hole. But that worked out really well. So links to everything is in the show notes. They don't have the 2004 2700 kV motor anymore, but they do have a 2004 2400 kV motor. I think that the 2400 will have slightly better torque than the 2700 kV that I'm using. I think it's going to be able to spin that 5x3 prop just as fast as my 2700 kV. So I think you're going to get just as much power from it. And I think you're going to get slightly better flight time. And I'm getting 8 to 9 minutes. 8 to 9 minutes of flight time with those little generic 2S lipos, 600 milliamp hour lipos. And it's got tons of power at the same time. So it's a very, very efficient power system that I've got set up. I am going to be pulling the trigger on a couple of those 2004 2400 kV motors. Those are going to work out really, really well for a couple of other projects I want to do. But anyway, links to everything is in the show notes, the ESCs, the props, the motor, the servos, the gyro, the receiver, the template that I use to fabricate the motor mounts. It's all in there. That's a wrap on this episode. Stay tuned, and I will see you in the next episode.